Points in higher dimensions. If a point in one-dimensional space can be described by a single number, and a point in a two-dimensional space can be described by a pair of numbers, and a point in three-dimensional space can be described by three numbers, then a point in four-dimensional space can be described by four numbers. For example, some points in four-dimensional space are 3, 2, -1, 7, 4, 9, 8, 0, 3.7, 9.01, -0.8, 16. Any four numbers describes a location in four-dimensional space. Graphing it, very, very difficult, although we will try to talk about that in the next class. Similarly, 5, 0, 9, 1, 6 is a point in five-dimensional space, and 1, 2, 3, 4, 5, 6, 7, 8 describes a point in eight-dimensional space. There are many real-life situations where high-dimensional numbers actually appear. For example, a weather station keeps track of several numbers at each moment. It keeps track of the time, the temperature, the barometric pressure, the wind direction. If you can say, I guess they usually say that 0 degrees is due north and 90 degrees is due east. So giving a number from 0 to 360 gives you the direction of the wind speed, the percentage of cloud cover, and probably a lot more things that I don't know about. In any case, the data of a weather station exists in 6 or more dimensional space. It would be very hard to plot all of this at once, but it's not very hard to store it on a computer. Probably they only deal with some of the stuff at once, but I'm sure maybe even the computer would keep track of several things at once. The temperature, the barometric pressure, humidity, forgot about that one. Similarly, new cars are constantly keeping track of many different variables. The speed, the acceleration, the position of the brake and the gas pedals, the state of the airbag and the seat belts. The airbag is probably a very simple number. It's probably 0 if it's closed and 1 if it's been deployed. But I don't know, maybe they keep track of how much air is in the airbag at any moment, which is usually 0. This again is recorded on a computer chip as a set of numbers, which exists in a multi-dimensional space. Now, it keeps writing over these numbers, so it only keeps track of the last 30 seconds or so. But if your car gets smashed up in an accident, they can break out the computer, analyze it, and tell how fast were you going when you got in this accident. If you swear you hit the brakes, they can tell if you're lying or not, because they can tell whether the brake was pressed down or not. So that's something to be aware of if you have a new car. Old cars, not necessarily. For another example, here's my favorite example. Consider this welding robot. Bang! Oh, look, it's a brand new welding robot. Hey, the robot appears to have 6 different joints. I figure it can swivel down here, 1. It can turn here, 2. Turn here, 3. This thing probably turns around, 4. 5. And this thing probably swivels, 6. Maybe there's more. Maybe there's stuff I'm not aware of. It also can weld, but I'm going to say it has 6 different joints. Now, if we consider the position of each joint with a single number, say, it turns all the way one way and all the way the other way. Well, if all the way one way is 0, we'll call that not turned at all, and all the way the other way is 100, you could keep track of how much each of the 6 joints has been turned at any given moment. So every position the robot could possibly be in can be described with 6 numbers. What's the first joint at? What's the second one, third, fourth, fifth, sixth? So if I gave you all the numbers, you could tweak it and put the robot in that position. You could tell exactly what it was. Now furthermore, so that means that every position of the robot is a point in 6-dimensional space. But here's where it gets interesting. Not all of those positions are good. You might be able to imagine that the robot arm could kind of swing down and try to snap off its welding tip on the base. It could bring this all the way down and then just try to smack it across that. The robot shouldn't be allowed to do that. The robot, if it's welding, it certainly shouldn't weld this wire here. It shouldn't weld itself. You should keep the robot away from certain positions. So it's not cool to have the robot in any of the 6-dimensional space positions that it could possibly be in. You should prohibit it from doing things that would break it. And this results in a rather tricky problem involving high-dimensional mathematics. So a lot of people think the 4th dimension involves time travel or aliens or something like that. It's not nearly as exciting as that. A 4-dimensional point is something like 4980. And in the next class, we're going to try talking about how to look at these things, how to imagine them.